Hi guys, welcome to your practice test video. I'm going to go through these problems pretty quickly because if not, this will last forever. So if you need to watch anything, I'll put it on, it'll be on YouTube so you can skip around, watch what you need to, do whatever you need. So here we go. First one, if you can't find the same base, which you can here, you need to take the log of both sides. And don't forget the exponent always goes in front of the log. So I'm going to do that, put the log both sides. Then to get the x by itself, just going to divide both sides by log 4. Punch it in the calculator. When you punch it in, as I've said all week, make sure you close your parentheses around your 25 and your 4. Make sure it works correctly. You should get 2.3219 on that one. All right, number 2, same kind of problem. Put the exponents in the front to get x log 18. You could also do ln if you want to, natural log, and you get the same answer regardless. Because I have x's on both sides, I got to combine them, so I'm taking the negative 3x log of 8 to the other side with the other x, make it positive. And then the secret here is to factor out the x. So I'm going to take the x out, gives me log 18 plus 3 log 8. Now I'm not going to show this, but what I'm going to do right here, that 3 is really the exponent on the 8. So it's really 8 cubed, which is 512. There's a plus sign. Remember, you cannot add logs. You multiply them when you see addition. So I'm doing 18 times 512. Let's see what that is real quick. That's a little above my pay grade. It's 92. So I get log of 9,216 equals 0. Now, to solve this, I'm just going to divide by the log on both sides. And if you do 0 divided by anything, you get 0. All right, perfect. Number 3. Number 3, same kind of problem, except now we have e. When you have the e, remember you got to use natural log. So I'm going to do 4t, natural log of e equals natural log 50. Exponent goes in the front. Natural log e is really just 1, so that's gone. So I have 4t equals natural log 50. Divide both sides by 4. What I'm going to punch in my calculator is natural log of 50 divided by 4. Doing that right now. I'm getting 0.7824. That's a 7 right there. 7, that looks terrible. 0.7824. There you go. Number 4. 4 might be the longest one we have on the front page because the exponents are so big. Exponents go in the front. And I'm gonna go ln this time just to keep it fewer letters. 1 minus x is natural log 4. 2 keys to this problem. The first key is, just remember, on this next step, you need to distribute. So I'm going to take the natural log 5 times both things in there. X times natural log 5 and 2 times natural log 5. Over here, 1 times natural log 4 minus x times natural log 4. Now, just like I won a minute ago, I need to get the x's together. So I think I have this term and this term on the same side. This term needs to go to the right-hand side because there's no x's. So I'm going to just flip-flop those 2 terms. So I'm going to do x natural log 5 plus x natural log 4. On the other side, I have natural log 4 minus 2 natural log 5. Key step here, factor out the x. If I factor it out, it leaves natural log 5 plus natural log 4. Over here, I'm going to do this. That 2 is really the exponent on the 5, which makes it 25, by the way. It's 5 squared. And I see subtraction, which means division. So I'm going to make that 1 log by just doing those 2 steps. Also over here, I have natural log 5 plus natural log 4. When you do addition, you can't really add logs. You multiply the 5 times 4 and get 20. So you end up here to get natural log of 4/25 divided by natural log of 20. I'm going to punch that straight in. Natural log 4/25 divided by natural log 20. And I'm getting negative 0.6117. Let's go to 5. Number 5, this is a weird one too. On this one, you must multiply the whole thing by e to the x. And the reason we're doing that is not to have a negative exponent. So if I do e to the x times e to the x, I get e to the 2x. That takes care of that term. If I do e to the x times the second term, I would get, you add your exponents, which would be e to the 0 power, which is just 1, or just 1 times 6. And then if I do 1 times e to the x, it's e to the x. All right. Let's move everything over so I can factor. All right, and if I factor that, I'm going to get e to the x minus 3 and e to the x plus 2 because negative 3 into 2 gives you the 6. So I get this, e to the x equals 3 and e to the x is negative 2. I'm going to do natural log of everything up here because what that does is it takes care of my e, gives me x equals natural log 3, which, by the way, is 1.0986. And if you try to punch in this natural log negative 2, your calculator is going to give you an error message. It won't do it because you can't do log of a negative number. Let's go to 6. 6, if you see a log, one log, you do the 5 to that power equals that. That's the pattern. So I'm going to say that x equals 5 to the third power, which is really 125. X is 125. Let's go to 7. 7, same deal. If you see natural log, the base is really e, and you do the same thing. E to that power equals x. So I'm going to go x equals e to the negative 5th power. Just punch that in. E to the negative 5th. I'm getting 0.0067. All right, see if we can find 8. 8 has 2 logs and are subtracted. Remember, when you subtract logs, you don't really subtract. You really combine them using division. So I'm going x over x plus 3 equals negative 1. Don't forget the base right here is really 10. Now I'm down to 1 log, so I'm doing 10 to the negative 1 power equals that. So 10 to the negative 1 power is 1/10 because it flips it. When I get here, I'm going to cross multiply 10x this way, x plus 3. Move the x over, divide by 3, 1/3. All right, let's go to number 9. See if we can find it. There it is. 9, just a tad bit different. It's got log with subtraction in it. So it means division. So I'm going to combine these two on this side by dividing x plus 8 over x plus 1. That equals log base 3/6. Now, the cool thing here is once you get one log on each side, maybe you can drop the logs out to set everything else equal. So I'm going to say x plus 8 over x plus 1. But remember, do not do that until you have one log on each side. Now I can cross multiply. 1 times x plus 8, 6 times x plus 1, which would be 6. Move the x over with the 6x, move the 6 over with the 8, divide both sides by 5. Don't forget when you do this also, when you have log equations, I didn't mention this on the last one, make sure you check your answer to make sure it keeps the logs positive. You cannot have negative logs. Number 10, have a division again, except this time with natural logs. You do it the same exact way. Divide the x by the x minus 4 equals natural log 3. Now, because we have one log on each side, you can cancel the logs out. Gives you x over x minus 4 equals 3 over 1, or just 3. Cross multiply, I'm going 3x minus 12. Multiply that way, you get 1x. I'll move the 3x over here, make it a little quicker. Negative 2x divided by 2. Negative 2, you get 6. Double check the 6, make sure it keeps it all positive. It does, it's great. Let's go to 11. Now 11 has addition on both sides. All right, so to combine the logs, I'm going to use multiplication. You know that. So same thing on this side, use multiplication. Now look what I have. Once I do that step, I've got one log on each side, which means now you can just drop the logs out. Gives you x squared plus x equals 2x plus 6. And because I see that x squared, what goes through my mind is that means I'm going to have to factor probably. So I'm going to move that x over, make it negative x, move the 6 over as well, and then factor it. So that's a 2, by the way. So make that x minus 3, x plus 2 equals 0. So my two solutions would be 3 and negative 2, maybe. Now if I plug negative 2 into that first log, it makes it negative. So negative 2 is out already. If I plug 3 in there, everywhere, it all looks good. So 3 is a good answer. Now I've said this all week. Don't just think because an answer is negative means it does not work. You need to check it and make sure. As long as it keeps it all positive, it's fine. But if it makes the log negative, it doesn't work. Okay, number 12 has one log. And don't forget, the same thing we've done a few minutes ago. When you have one log, you go the base to that power equals that. So I'm going to say 8 minus 7x equals 2 cubed. Now 2 cubed is 8. So if I move this 8 over there, obviously it's going to be 0. Divide by negative 7, it's 0. Make sure it works. It does. We're golden. All right, 13. 13 is the growth problems we did yesterday. The formula, in case you need it again, is P of t equals P sub 0, which means original amount, E, which means E, to the kt power. K is the rate that it's growing. T is the time. All right, so 13 says the population of Mexico was about 113.7 million in 2011, and the exponential growth was 1.1% per year. That's our K. Part A says find the exponential growth function. So when it says just find the function, you leave the T in it. The initial amount was 113.7. K is going to be 0.011 t. All right, leave the t in it. That's the function. Then it says, what was the population in 2016? Well, how many years away is 2016 from 2011? It's 5 years away. So basically, you're finding p of 5. You're putting 5 in for the time, the t. So I'm going to go 0.011 times 5. I'm going to punch that in real quick. And I'm getting 120.1 million when I punch that in. I want to make sure you might want to punch that in just to make sure you're punching it in correctly. Okay, 14. Suppose that $3,000 is invested at an interest rate K, which means we don't know what K is, compounded continuously, which means we can use the growth formula, and it grows to 3,600 in 5 years. Okay, what's the interest rate? So we got to find K first. The P of T means final amount. In this case, the final amount was 3,600. The P of O is initial amount. We have E. I don't know K, but I do know the time. It says 5 years, so I'm going to put 5 in for my T. To solve this for K, first step is divide both sides by 3,000. If you do that, you get 1.2 equals E to the 5K power. And obviously, I need the E to go away, so I'm going to do natural log of both sides right here, which takes care of that. So to get the K by itself, I'm really going to do natural log of 1.2 divided by 5. I'm going to punch that in real quick. Divided by 5. I'm getting 0.036. So that's our K. That's our rate. Okay, then it says find the growth function. So I just write the function. So I'm going P of T equals 3,000, which was the initial amount, E to the 0.036 t power. Remember, when I ask you to write the function, leave the t in it. Part C, what will be the balance after 8 years? Okay, after 8, that means we're just doing P of 8. All right, so I'm going to plug 8 into the function we just found. So I'm doing 3,000 e to the 0.036 times 8 power. Let's see what that gives me. I'm going to punch that in real quick. When I do that, I get $4,001.27. All right, and there's that one. The last part, how long will it take to double? Made a big deal about all that yesterday when we double something. Remember, you can go ahead and skip to the part. You don't really have to put the initial amount and final amount because we're going to divide that first anyway. And we're going to end up with the 2 every time we double. So I'm going to say E to the 0.036 t. I'm looking for time. How long will it take to double? So go ahead and do natural log both sides. Okay, over here, I just have this. Over here, I have natural log 2. So to get my answer, I'm just going to divide that natural log 2 by 0.036. Punch that in as usual. And I'm getting 19.2, actually 19.3 years to double your money right there. Hope that wasn't too bad. I'm going to erase this so we can get this next one. We're almost there, believe it or not. 15, find all the zeros. Okay, to find the zeros, first thing I'm going to do is I'm going to make a list. I'm going to go plus or minus the factors of the last number over the first number. Okay, so this is where my list is coming from. 3 halves, 9 halves, 27 halves. Then I'm going to punch in my calculator and see where it crosses the x-axis. So when I do that, it looks like this may be a case. Looks like it may cross at -3 halves. All right, so I'm going to put that in the box to make sure it crosses there. And I'm going to bring down the 2 first. Multiply, that gives me -3. That's gone. Multiply, add, multiply. It does. It got 0 at the end. That's awesome. So take what you have left right here. Take the 2x squared plus 18x. It's just 18, not 18x. Set equal to 0. Let's move the 18 over. Divide by 2. And take square root of both sides. When I take the square root of both sides, I get this. I get plus or minus 3i. All right, so those are my other two. So my final answer is this. All the zeros are -3 halves and then plus or minus 3i. Those are the 3 zeros for 15. And the last one, number 16. All right, it says solve that inequality. Factor first, x plus 2, x minus 1. Did this a while back. And my zeros are going to be -2 and 1. But what I'm going to do with those, remember, I'm going to put them on the number line down here, -2 and 1. I'm thinking this is coming back to you now. I'm going to plug in 100. If I plug in 100, that's going to be 102. That's going to be 99. If you multiply those together, you get a positive number, which means it's negative there and positive there. Look at my sign here. I'm looking for greater than 0. Greater than 0 is positive. Where are the positives? They are from -infinity to -2. And also from 1 to infinity. So there's the solution to number 16. Guys, I hope this helps. Use it as much as you need to. I'll be at school early in the morning. Come see me sometime before your test if you need any more help. I'll see you then.